All right, so you just got done learning about solving for two variables. When you have two clues and two equations, you can solve for those two. Well, hey, sometimes you got three equations and three variables to solve for. Yes. So we're going to go through three different examples. And this first one is actually a word problem. So I want to set it up first, and then we're going to go on to the other two, and then we're going to come back to it, okay? So this is solving three variable systems. So I just want you to see how there could be three things going on in this problem. So let's read this carefully. Billy's restaurant ordered 200 flowers. Some of them were carnations, and those were $1.50 each. Some of them were roses, and those were $5.75 each. And some were daisies, and those were $2.60 for every single one. They ordered 20 less roses than daisies. See, there's a clue right there. We get equations from clues. And the total order, if you add it all up, was $589.50. Sounds like we got a lot of clues there, and we could probably get our three equations here pretty easily. So let's introduce some variables. We'll use C, we'll use D, and we'll use R. So carnations, roses, and daisies. All right, now it says they ordered 200 flowers total. So that's pretty easy. We would take C plus D plus R. All of that equals 200. By the way, I'm writing kind of small because honestly, there sometimes is a lot of work to do when you have a 3x3. Okay, they ordered carnations at $1.50 each. Okay, so if we start adding up the cost, it would be 1.5 C plus roses were 5.75, and then daisies were 260. Let me zoom in a little bit here for you. Okay, so there's our two equations so far. This is a plus sign right here in between these two. Now, what's the third one? It was this one where I said, hey, that sounds like a clue. They ordered 20 less roses than daisies. They ordered 20 less roses than daisies. So which one's bigger? That's sometimes what I ask myself. Daisies are more. So daisies is the number of roses plus 20. Or you could write it differently. You could say R equals D minus 20. That works also. Okay, so then we would go through and we would solve that system. Now, before we do this system that has some nasty decimals in it, I really want to go to one that's maybe a little bit more traditional. Then we'll come back to this one and see if we can figure it out. Okay, so, oh, I'm sorry. And I didn't finish that second equation, did I? I really felt like something was missing. It all adds up to $589.50. So that's the completion of that second system. All right, so here we have a 3x3 equation that we're going to solve. It's going to be a little easier than that first word problem. So that's why I wanted to kind of lead with this. We're going to have to combine these three clues in different ways, and we have to use all three clues in order for this to work out. So what I notice, I'm going to use elimination method, and what I notice is that this equation is going to be very handy because it's a 1, 1, 1 situation. I could use it to eliminate any variable I want. I'm going to say, why not? Let's eliminate this 6x. So I'm going to do a transformation. I'm going to multiply this first problem, this first equation, by -6. So I get -6x minus 6y minus 6z equals -12. Don't forget to multiply the right side as well by that number. Now I'm going to use black here because I'm not changing the second equation at all. And again, I'm writing kind of small because we have a lot of work that we have to show here, and we have to stay organized. Please take your time, write neatly when you're doing this. It helps tremendously. We then add these equations up, right? That's what we do when we do the elimination method. And I get So that would be 19. 19. All right, and notice I have a YZ equation. I'm going to just tuck that off to the side over here. Negative 10y, move down a little bit for you. Negative 10y minus z equals 19. We're going to hang on to that. We have to, in fact, have another YZ equation in here. It has to be a YZ equation. It can't be like XY or XZ. It has to be YZ, just like the first. So we're going to use the first equation. Now listen to me carefully. You have no choice, but you have to use the third equation because we haven't used that clue yet. So you have to use that clue at this point. We have to use the 5x, and you just got to figure out a way to eliminate the x. Because remember what I said? We need another yz. So I got to eliminate this 5x. How am I going to do it? I'm going to take the first equation, which I said was really handy, and I'm going to multiply by negative 5 this time. So that'll be negative 5x minus 5y minus 5z is negative 10. Now I will take that third equation and we have this here. I then add them up and I have my YZ equation, so I'm excited, right? You can see it here in my voice. I'm pretty excited. Oops. Negative 3y minus 3z equals negative 3. And by the way, if you want, you could actually divide everything there. You could divide everything. I'm just checking my work here. I feel like something went awry, so I just want to double check, folks. Multiplying by negative 5. Yep, everything looks good. Okay. If you wanted, you could divide everything by negative 3 and actually make that a little bit useful. Let's just do that. I'm going to divide the entire equation by 3, actually negative 3. So I get y plus z equals 1 because negative 3 divided by negative 3. So you can do this. You can manipulate these equations as long as you follow those rules that we've talked about when solving equations. For example, you're allowed to divide everything by a number. So that does make our life easier because then I have a new problem to work up here. I've got it whittled down to only 2 variables. How cool is that? Pretty cool, Mr. White. So go ahead and add this up. And did I copy? I feel like I missed a sign somewhere. You're probably screaming at the TV here, right? All right, I multiplied that by 2, negative 6, 31, negative 5. Nice thing about showing all your work is you can follow your logic. Negative 3, negative. Oh, I see it now. You know exactly what I did, didn't you? So this should be positive right here, folks, which means this up here should be negative. That's going to be nicer, I think. So now I get negative 9y equals 18. Aha. See, I knew something went wrong because that was going to come out to be a decimal, and I knew that couldn't be it. So I'm going to divide by negative 9. Divide by negative 9, I get y equals negative 2. Y equals negative 2. All right, so what do we do next? Well, you grab any equation on this paper, anything, anywhere, and it's valid. Well, I see a really useful one right here. Y plus z is always negative 1 in this universe, in this system. Think of it like a solar system. In this solar system, y plus z is always negative 1. So if I put negative 2 in here, make sure you show your work so you don't accidentally write z equals negative 3. I see that a fair amount on quizzes and tests. So I've got 2 of them. How do I get the last one? I go all the way back to the beginning. I'm going to grab this right here. X plus y plus z is 2. And z is 1. y is negative 2. We don't know x yet. We're going to figure it out. These guys add up to be negative 1. Then you add 1 on both sides. You see x is 3. So the answer to the riddle is 3, negative 2. And if you want to write it like this, an ordered triplet, 3, comma, negative 2, comma, 1. X, Y, Z. There you go. Okay? So it involves transformations, and you just got to get them all put together, combine them together, but make sure, remember what I said, you have to use all 3 clues. I used all 3 clues. So in my first process, I combined the first 2, and then the second process, I combined the first and the third. So I did manage to get all 3 clues. So I would suggest maybe you pause the video and see if you can try this problem on your own and see what you can do with it, and I will go over it. All right, so what I noticed right away as I'm evaluating the easiest way to do this is that if I add these 2 together, the x's cancel right away. I think I want to do that. Let's just go ahead and add these 2 together, and I get y plus 2z is 3. Easy peasy lemon squeezy. Now remember on the last one, I have no choice. I need another yz equation. So I got to figure out a way to get rid of this negative 2, or this 2. And I can use any of the equations, the other 2. So I'll just use, why not? Let's be a little different. Let's use the second one and let's multiply by 2, because then it'll be negative 2x plus 6y minus 2z equals negative 12. I then combine these 2, and I'm going to write it up here. So I'm doing a little bit more shorthand this time. I'm sorry, that first one was off the screen. I didn't even notice. There you go. So we add these together, and we get y plus 3z equals 5. Zoom in here. Here's my new question to solve. And this is a really easy transformation. You just change all the signs, and then you see the y's are going to eliminate. So I'm going to do that, and I get negative z is negative 2. So if I divide by negative 1, I get z is 2. Then, just use one of these. It doesn't matter. Y plus 2z is 3. So if I subtract 4 on both sides, y is negative 1. Then go back to one of the original equations. X minus 2y plus 3z is 9. So x minus 2 times negative 1 plus 3 times 2 is 9. That's 2 plus 6. So that's x plus 8 is 9. Now, it's not 17. Show your work. And you get x equals 1. X equals 1. So the answer here is 1, negative 1, 2. X, Y, Z. All right, so there's a 3 by 3. I went much faster that time. I tried to even consolidate, write my work a little bit more nicely there, a little less writing, and I still got the job done. I kept it organized, so I didn't get myself confused, and even if I made a mistake, I could probably go back and find it. All right, so hopefully that helps on that one. Let's now go back to our word problem. Remember, we set it all up, and we're going to figure out how much they bought. All right, so I do see that there's a couple ways to do this, folks. What do I want to do here? All right, let's substitute out the D. Let's just use a little bit of substitution here. C plus R plus 20 plus R is 200. You see what I just did? You see what I did? This D came out of the ball game, and I substituted an equal player in there because the third clue says that D is the same thing as R plus 20. So this used to be a D, C plus D plus R, but now it's an R plus 20. So that means that C plus 2R equals, if I subtract 20 on both sides, I get 180. So here's one of my equations that I'm going to use. Now I have to get another CR equation. So I have to eliminate this D right here. Again, a couple ways to do it. I just want to eliminate that D. I've already used the third clue, so I don't have to worry about using that. I have to use the second clue because I haven't used that yet. But I could either do substitution here, or I guess I could even do a transformation. So here I'm going to mix. Let's go ahead and do that. Let's mix elimination with substitution a little bit. I'm going to multiply this first equation by negative 2.6. And the reason is because then I'll be able to eliminate this guy right here. So I get negative 2.6c minus 2.6d minus 2.6r equals, I'm going to go to my handy dandy calculator, 200 times 2.6, negative of course, is negative 520. Negative 520. So now I have this equation and this equation to add up. And I'm going to just write it down here to save some space. Okay? So I get negative 1.1c. That's where I add this and this right there, folks. No D's. And now I have to add this and this. And I get plus 3.15R equals 69.5. Now we have these two equations down here. We have a new problem to work right here. And it looks to me like I'm going to transform this by multiplying by 1.1. And we get 1.1c plus 2.2r plus, and then go to your calculator, 180 times 1.1, and I got equals 198. Right now, I'm going to add those together. I get 5.35R equals, just double checking here, 69.5 plus 198 is 267.5. Divide by 5.35, and you have your fingers crossed, right, that you don't get a decimal. And would you believe they bought 50 roses? Oh my gosh, it came out perfectly. Whew. All right, so let's come over here. Carnations is 2 times roses. We're literally home free at this point, folks. That first one is really a pain in the butt to get. Once you got it, you're good. Carnations, they bought 80 of those. How many total flowers did they buy? 200. So 50 plus 80 plus not carnations. What was the other one? The daisies. Daisies is 200. So if you subtract 130 from both sides, you see the number of daisies is 70. Goodness sakes. So we did all that without I had to use my calculator occasionally, right? Had to use the calculator, but that's all right. We did it eventually without even using Desmos. Now we could have maybe used Desmos at this point right here, and we could have solved for C and R using either a graphing calculator or Desmos, and that would be pretty handy. But hopefully you saw how to do these 3x3 systems. All right, so I know it takes a lot of effort to, whoops, wanted to start my music. There we go. I know it takes a lot of effort sometimes to get these things going, but hopefully you see how you just eliminate one of the variables and you're going to have some success. All right, until next time.